Good afternoon, teacher. My name is Ricardo Alcántara, and today I'm going to expose my thesis. This thesis consists of 3 parts: a description of the research problem, SD1 technology, and development and methodology. So I begin by asking probably the most important question. What problem can we find in a bank today? And more specifically, a bank owned by the government or the state. Well, the banking entities has currently security, administration, and applications with slow speed problems. This means that customers who attend the branches of this bank receive a low quality in the services provided by said agency. The only element that provides security to the network is a firewall that is located in its data center. So each agency is vulnerable. Any employee of the company that provides the MPLS service could connect to internal agency devices. The administration of each agency is a recurring problem for the bank, since there is no management of what elements are inside the branches. It is difficult to know when one of those elements is having problems, so fixing them takes longer than normal. The last problem that the bank has is the low speed of its applications. This because the bandwidth it needs to work correctly is not enough, so the offices present saturation in their links. Increasing the bandwidth of an agency will represent an extra expense of several thousands of soles, and this multiplied to the number of agencies that this bank has throughout the country is not viable. As a proposed solution to this problem, the design of a software-defined network, or SD1, is presented, which will not only solve the problems of having low bandwidth, but will also give the bank better management and security of the devices that it has within the agency. Before getting into the world of virtualization, we must understand what elements are currently inside the bank's network. Let's talk about the LAN and WAN. A LAN is basically a set of communication devices such as cables, access points, switches, routers, and other components installed in a limited area that allow devices used by users, such as computers, phones, or even cell phones, to connect to each other, or to other internal servers, web servers, and other LANs over wide area networks. A wide area network, on the other hand, is named like that because it extends beyond a single building or a campus to include multiple buildings spread across a specific geographic area, or even the world. It is made up entirely of routers and uses routing technologies and protocols such as MPLS that allow the connection of thousands of LANs, including the LANs of different offices of the same company. Speaking of company, we must mention data centers, which are physical facilities that organizations use to host their critical applications and data. All the branches of a company, such as a bank, must be connected to its data center. Otherwise, they could not have the different services found on those servers, which are ATM service, telephony, platform user service, etc. But how are these branches connected to the data center? How does a branch in Tumbes do that when the data center is located in Lima? That is where the telecommunication service provider, or ISP, comes in, and the MPLS technology. A common ISP in Peru is Telefónica, which offers the connection service between branches and data center, making use of the huge WAN network that it has. It also uses the MPLS technology that uses labeling of the packets that are sent and received, creating a private network, protecting the information and giving certain performance to the shipment or to the traffic. The problem that we can find in this is the elevated price of megabytes per second and the MPLS technology, which, although it was efficient 10 years ago, today that is no longer the case. This is where SD-WAN technology comes in. SD-WAN is a software-defined wide area network, a virtualized management solution that resides over the top of enterprise wide area networks. SD-WAN gives branch offices, remote workers, and distributed workforces access to corporate applications, resources, and services, all manageable through one centralized dashboard. SD-WAN separates the control and management layer from the networking hardware so that management can be handled via software. Security, access, and governance policies can be applied across every device on the network from a single pane of glass, providing global and granular control, and thus a consistent approach regardless of where workers are or what devices they are using. SD-WAN does not replace your WAN network services. SD-WAN solutions act as an overlay to work with and optimize your WAN. SD-WAN supports and manages your entire network with a secure solution and can accommodate multiple configurations. SD-WAN benefits every aspect of your network, from increasing reliability and security to prioritization and diversity. In case of a failure, your SD-WAN solution will automatically divert traffic to create seamless connectivity. Many organizations today are using a mix of private lines and internet for connectivity. If one of the links has a disruption or becomes congested, you can leverage a more optimal connection. SD-WAN will route traffic to the best available connection without dropping a session, which is very important. It happens in the background, without users experiencing any downtime or delay. Part of building resilient SD-WAN solutions is integrating end-to-end security that goes well beyond just encrypting data, replacing aging SD-WAN security or third-party security solutions with an integrated next-generation firewall, IP and URL filtering, antivirus protection, and intrusion prevention systems simplifies management while enhancing security. SD-WAN will ultimately organize traffic to prioritize real-time applications, such as video conferencing or VoIP, that demand minimal latency, both of those applications, allowing efficient access to cloud-based resources without needing to backhaul traffic to centralized locations, reduces latency, and provides a better user experience. SD-WAN is application aware, so that demanding applications get the bandwidth they need. Another of the SD-WAN benefits is that it can split traffic across multiple providers. In the event of network congestion, your SD-WAN will route traffic for optimal performance. Networks today get complex quickly, especially with multiple locations, hybrid and multi-cloud options, and distributed workforces. Traditional circuits may struggle with the volume of cloud traffic routing across multiple locations rather than a single data center. SD-WAN handles multiple locations and connectivity options seamlessly to ensure high availability applications performance. We have the SD-WAN orchestrator. This is the virtual platform where we can access from anywhere and monitor, configure, diagnose, and receive reports of events and alerts from our network. We have also the router edge. It will be necessary hardware that we must install in both data centers and in the bank branches in order to make use of the SD-WAN technology. We have some requirements that we need to meet in the design. First, we have functional requirements. The solution spans 2 data centers and 500 agencies nationwide. Branches will now be able to communicate with each other without having to go to the data center. For the tunnels, for the SD-WAN tunnels, we will use private networks contracted to Telefónica or Claro. We have also the routing requirements. The data centers will use the BGP protocol to reach the agencies. The internet connection from the branches is given through the data centers. In the branches, the MPLS routers will be replaced by the HD-WAN edge, which will supply the routing needs of each branch. We also have the high availability requirements. In each data center, we will install a cluster of edge hubs so that if one falls, the traffic can be covered by the rest. Each physical equipment in the cluster must have redundancy at the connection level for each private cloud. 3 private clouds in total. Telefónica is number 1 and 2, and Claro will be number 3. We also have, finally, the security requirements. Internet traffic from all branches needs to be directed to the data centers, and applications traffic must be inspected and allowed by the architecture of firewalls in the data center. We have the data center topology. 2 data centers are managed that act as hubs for the entire network, and at the component level, they are a mirror of each other. There is design of a multi-layer switches that interact to provide connection between each respective data center, its internal network, and the MPLS clouds. There are PE type routers, 1 for each private network, which are the ISP routers that manage IP and MPLS, and CE protocols, and CE routers in the branches and data center. These are the company's routers, which are in charge of routing the bank's network. The routers to services in the data center are summarized and shared by the core switches via protocols to the switches at the WAN aggregation layer, which redistribute these routes via BGP to the local CE and subsequently to the PEs of each MPLS provider, who in turn share them to all the other PEs in the branches. Then, the local PEs of each branch share these networks to the CE using BGP as well. In turn, the CEs of each branch share the local routes with the local PEs of each provider, so that they can be distributed by the same to all the remote PEs of both branches and data centers. At the security level, there are 3 firewalls per hub. There are firewall DC, internal firewall, and external firewall. Each handles control to different services. We also have the agency topology. We will have 2 types of agencies. The difference between them is the number of WAN links they have. In both, we can find Cisco routers and switches routers, and Cisco switches, which belong to the company. We can also find ATMs of the Diebold brand, telephones, and other devices. We also can find an ASP router that belongs to Telefónica or Movistar. The applications used in the agencies and located or almacenated in the data centers are the IP telephony, ATMs, mail, and proxy navigation. The mail, navigation, and telephony will be used by the users of the agency, and telephony and ATMs will be used by the clients. Methodology. It contemplates making physical and logical changes in both data centers and in the 500 agencies nationwide. As we have already seen, in the data centers, we find router headers, which serve as an exit to the ASP1, and WAN aggregators that group the MPLS links that arrive at the data center in a single logical connection, giving some extra performance to those connections. What we will do in the data centers will be to install a cluster of Edge 3800 hubs in the middle of those two devices to have the SD-WAN functionalities. In the case of branches, we can find Cisco and switch, Cisco router and switch, diable brand ATMs, and an ASP router from Telefónica or Claro, as we mentioned before. What we will do is replace the Cisco router with the Edge 610 to give us the SD-WAN functionalities or capabilities. Before making this change, the Edge router must have obtained a specific configuration in the SD-WAN orchestrator. For this to happen, it must be connected to the internet. Once we have deployed this new router in the branches, we will have the new functionalities of SD-WAN, which we can see from the orchestrator anywhere in the world. We can use this tool to, as we mentioned, diagnose, supervise, or configure the network in our agencies or even in the data center. So that will be all, teacher. Thank you for your attention.